Welcome everyone to GeoHag. I'm Jess from Prospectors and CallSafe. So I'm just putting in the chat now. We've got heaps of cool stuff that's getting covered by John today, but we'll be moving through the slides quite quickly. So I've just put a link. You can download the PDF and look through the slides in more detail afterwards. If the link doesn't work, just send me an email. I'll put that in there now. And I can send you the PDF afterwards as well. But yes, a big thank you to John Greenfield from the Geological Survey of New South Wales. So they've certainly been very busy over there. So John has heaps of awesome stuff to share with us today. So thank you so much, John, for your time. I'm so appreciative that you've come on.
No worries. Thanks, Jess. And I hope Harry hangs around because there's some really cool pics, even if he doesn't understand, you know, like the details of it. But that's fine. So this is latest data and insights, but really this is just a fraction of what we're doing, and it's all stuff from some of my area. So there's just so much more all going on in the survey. I couldn't even include all the stuff that's just come out from our own people. So, but there's a list of all the stuff. I will go through it reasonably quickly, but you've got the PDF there to check out in a bit more detail. You can always contact us as well. So firstly, I just want to give you a bit of context of the survey overall. We're involved in MinXCRC, which is the world's largest mineral exploration collaboration. So this is going to be, it's a 10-year thing. We'll be involved with this right up until 2028. And it's just about developing new kit, making drilling cheaper and faster and safer, and also building tools to get new real-time data and analysis on the drill rig. So that builds on the previous CRC, but what we've got now is this National Drilling Initiative, and that's where we come in. So we're going to put all this new kit to use and go and check it out in these new areas. So we're looking at the data. That's what Project 7's about. Project 8's about the geology, and Project 9's about how we put it all together and look for new deposits undercover. So good stuff. And we're up and running, and these are our areas. So we have got 5 areas, but they're just extensions of our big deposits in New South Wales. So obviously extension of Broken Hill. We've got the extensions undercover for Cobar and the extensions undercover for Macquarie Arc. So they're the areas we're putting in 16 million over 10 years. And this is a little bit busy, but hang in there. So this is just Cobar in here. There's Broken Hill Mundy, and there's the Mac Arc. And if you just tune into the colours there, that's the stuff, that's the pre-drilling that we're doing. And it follows it very similar to any exploration project. So we're doing data synthesis. And by the way, you can get all of our data analysis. So we've done a lot of audit and gaps analysis of the areas. You can get them off digs. We've done hydrogeochem and biogeochem, and I'll show you a couple of slides of that from Cobar. And we've done geophysics, and we're going to have a look at that as well. So that's where we are. We've got a long way to go, and we want to get to these yellow bits, which are the drilling. And we'll then have a nice little release of all the stuff we can release. And then we dive back into the data and try and make sense of it all in each of the areas. So a long way to go, but we're getting into it. And we've even just returned from Forbes, where we've been collecting more hydrogeochemistry. So the other thing broadly that's happening, so round 3 of our cooperative drilling is going right now as we speak. And we managed to get 22 projects funded, and mostly in the Central West, but you can see there's a really broad coverage there, mostly copper gold, but it's all got to be finished by June next year. Right, now the other thing that's happened in the space that I work in is we've just released the version 2 of the New South Wales Seamless Geology. You can get online and grab that. And in blue here in the outlines, they're the areas that have been updated. So, and what's really cool over here, you can see Lord Howe Island. So we did mapping there last year. Kate Bull was the lucky one who got to go over and fix up the maps. She's now with the Alaskan Survey. but that's now been put into our Seamless, so you can go onto MinView and check that out. And we've got it as a separate app. So Lord Howe Island reopens in September, so I really recommend you getting over there. We're going to try and get over there in October for a holiday, and you'll be able to have this app in your hand and have the geology right there with you as you're walking around. I'll just leave this slide. You can go and check this later, but this is where you go now, download the GIS. And news to some of you may be that we've actually now changed our phone maps. So for both Android and iOS, you can get online to your app store and look for that. And there's the symbol for it. It's an Esri app. But you can get all of our latest mapping and geophysics and have it in your hand. They're offline maps, but they're also vector, so you can sort of click on it and get more information about the units. So really recommend you get into that. So this is what's been updated in version 2. The biggest update has been East Riverina. So we've been mapping there since 2014. Really big project. And a lot coming out of it. That's the old mapping. The old mapping was 50 years old, so we've made huge advances in our understanding of the area. We've got over 7,000 observations, just a truckload of new isotopic ages and also paleo constraints. And we've really been able to tease out, especially the igneous units in the area, but also the Ordovician sedimentary units. So it's been a great project, and we're only just now just reaping the rewards of all the work. But here's just one example of new stuff coming out of it. So here's the time-space plot of the area. Here's our Ordovician sedimentary rocks, and this is the granites coming in. So this is the Coetong supersuite in here, and the old story for the tin belt was that all the mineralisation came in at 430. But with more mineral system studies, particularly at Ardlethan, and the new dating that we've been able, the constraints that we've been able to bring in, we've got a much tighter range, a younger age of the bulk of the tin mineralisation. So that's really interesting. And this is how it plays out. So before we started the project, we actually did some mineral prospectivity to have a look at where the hotspots were for tin in the belt, just using the old data. And you can see these are the reds are the hotspots where to explore, and they're actually quite a big area. And we've been working with Kenix, and this data will be released hopefully very soon. And you can see we've really constrained the areas that are considered highly prospective in that belt. We're going to talk about more of the Kenix work coming up. So what's to like about the new East Riverina mapping? And there'll be a synthesis map coming out shortly. So the other thing to note with the new Seamless is that we've added all fault attribution, all right? So that means for every fault throughout New South Wales, and there's about 100,000 of them, we've added all of this information you can get for every fault. So we tell you about what family the system lies in, what its geometry is, the architecture, how it dips, and how far it goes into the crust, what it looks like in geophysics, and what event it was active in, and what was the kinematics of that event. So this has been obviously a brain-bending job for the team that have been working on this, and it's taken us a good part of 5 years to get all this done, but now you can reap the rewards. And I'll just give you an example, and this is, you can do this as soon as the talk's finished, get into MinView and you go and you do text search, bring up your Lachlan Geology. So we are back down in the East Riverina here, and the Gilmore fault zone comes up through here. So imagine you're an explorer and you want to look for gold mineralisation, and your hunch is that in fact it's not, it's on the back thrust to the Gilmore fault zone. So we'll have a look at that. So you go for your boundary and faults here, and we go for parent equals Gilmore, and that's it. But that's quite a big system. There's a lot of faults in the Gilmore family. Not you, Phil, it's okay. There's no faults with you. But we want to look at second order faults, and so we constrain it down into there. and that's still a little too busy. So now we're looking for ones that dip to the east. And then we get that, and that now is our search base, just using that fault attribution. And then we can just look at, and this is a snapshot showing the gold mineralisation where it occurs along there. There are ones, of course, that go right into the Gilmore Fault Zone, but we've got a new report very soon coming out on gold mineralisation along that trend, and there is quite a bit of gold mineralisation in those back thrusts. Okay, so the other big thing that we've added to Seamless that you'll be able to download that's in MinView already is in the Cenozoic igneous province. When we put the Seamless together, we really didn't get a chance to get into it and sort out a lot of the groupings of these. We didn't have good dating, we didn't put it together. And we're lucky enough to have graduate geologist Brennan Simpson, who has already done his master's in igneous geochemistry. He was perfect for the job. He got right into it. He worked with Lynn Sutherland, who is an expert in this, and we've got a paper coming out actually shortly. But we've updated it all in the Seamless, and as you may know, it's divided into these two separate areas. So there's these Eocene lava fields from about 60 to 40 million years along the highlands here, and that was related to the opening of the Tasman Sea. So, but after that, in the Miocene, you have these hotspot tracks. So as Australia was moving away from Antarctica and moving north, we had this volcanism that punched right through continental New South Wales, and we've put all this together with the dating. You can see these ages as you know, Australia trucks north. These things are younging. So this mantle plumes heading south. And in fact, this Cosgrove track is the longest known. It's about 2,000 kilometres that can track it. Gets a little bit sketchy where it goes around here, but essentially that's a really long track. And of course, let's not forget Lord Howe Island, which is also on its own hotspot track, but much younger. Okay, so why is that fun and interesting? Well, we've also just embarked this year, just signed the paperwork for our involvement in this arc linkage project. Obviously, critical metals are certainly flavour of the month, and we've got Carl Spanler, based at Adelaide. He's heading up this new arc linkage project, and we've got our own Phil Blevin, who's partner investigator in this. So this is going to be a really good project, because most of the critical minerals, recognised rare earth minerals, are actually mostly in Western Australia, and mostly, you know, Mesoproterozoic or older. But we do have these Mesozoic and Cenozoic volcanics. So here we go, per-alkaline volcanic deposits. This is Toongai, as we all know and love, or should in this group. And Carl put out a paper on this when he was at JCU. And this is interesting because this also relates to the Cenozoic volcanism, and it's where you get, and we're going to have a look at this a bit later, but this is the lab. So this is the asthenosphere-lithosphere boundary. And this is where a lot of the action happens, where you get these steps in the lab. So between the lithosphere and asthenosphere, you know, nature loves a discontinuity, and it picks on that. Where you get sort of faults and upfluxing of material, that's where you can start seeing the source of a lot of this material fluxing out right through the lithosphere. And of course, as it's punching right through areas like continental New South Wales, it's going to pond and pool and batch and basically fractionate its way up till it gets right to the surface. So although we've got Mesozoic here, but this applies very much to Warrumbungles, which is my next little stop on the way through this journey. So we've been doing a fair bit of work here. In fact, we've just released a new map, which you can buy off us if you want the paper copy, but you can also just download the soft copy from DIGS. We've also done a new research paper, which has just come out, and we've made that open access for you. So once you get that PDF, just put that into your search engine, be able to download the paper. So senior all for Kate Ball, but, and this will be a bit of a theme. You'll find that everything I show you from now on, we've got collaboration, and this is no exception. We worked with national parks but also Geoscience Australia. Here's our own Phil Blevin and Michael Bruce, and Geoscience Australia's Kate Waltenberg. So what came out of the geochemistry, which was kind of known, but there was more of a complex story. I think we've simplified the story, and it is a per-alkaline complex. So that's where you get aluminium, potassium in excess of the available aluminium, and you get these beautiful sort of pyroxenes, sodium-rich pyroxenes and amphiboles, where you've got this excess. And this is just an example of that in these trachytes. And you can see these things, these are little flow foliations, and you've got arfvedsonite growing in these things. So this is sort of the end of the road for these immiscible liquids, you know, the extremely fractionated material that's just refused to find a home in a crystal structure on its way up, and now it's found itself frozen in these trachytes. So they're chock full of rare earths. Now, obviously, we're not going to go and explore in, except the beautiful scenery in Warrumbungles, but this is an avenue in other areas of the state to look for rare earths. Okay, let's move on. So Auslan. Now, this is another project that we're doing in consultation with GA, and we are basically putting out these stations on a 50K grid right across the country. You can see we're fairly advanced. If you can hear something, my neighbour has just started his drum practice, which is awesome. But you can see here, so in yellow here, these are the stations we've covered for Auslan. Now, funny enough, we just deployed all these ones in green here, and they are in fact still out there. We employed them deployed them in February. They're still sitting there, hopefully collecting data, which will be awesome because we're going to have really good data up there. But we really need to go and make sure the cows aren't chewing through the cables, and get them deployed in these blue and pink areas, which is all we've got left. So we're going to be finishing that by the end of the year. However, thanks to our friends at Geoscience Australia, they've already done modelling on our neck of the woods as it stands at the moment. And there's a paper just about to come out in tectonophysics, and this is on interpreting the lithospheric architecture. And this is Alison Kirkby from GA, who's heading this group up. Really good crew in Geoscience Australia. Our own Bob Musgrave, more GA people, and Ross Cowley from GSV. So it's fantastic data. The model is interesting, and what I love about this data, so we're looking here at the depth slice at 10K. So the blues here are more resistive, and then we've got these more conductive areas in the warmer colours. So they will hopefully give us an indication of, in the conductive areas, of where you've got conductive material fluxing up through, or where that's in the crust, or in fact right through the lithospheric mantle. So here at 10 kilometres, we can actually already see that it's respecting the known geology. I've got the mag sitting underneath here. So you can see that there is a geological basis for a lot of this conductive material as modelled, including this one, which we're going to come back to. Look at that. That is called the Curnamona conductor. It is an absolute ripper. We'll have a look at that in a minute. But we'll take you down through the crust. So here's 20 kilometres, and we're just seeing Cobar, and so this is Riverina and Granite coming up into Tritton, Cobar area. That's firing up, and we've got this strange conductor emanating from the sort of triangle edge of Curnamona. And now we're at 40K, and we're right at the base of the crust at the Moho, and really seeing the Riverina granite in this area south of Cobar really firing up. The Thompson's very distinct, and we know from seismic that it's crustally thickened there just north of the yellow ploca, which comes through here. And there, this thing that's emanating out with a very sharp, sort of apparently sharp boundary along the edge of the Cooneree belt. And that's of interest to me because, of course, that's my old mapping neck of the woods. And I know that this area in here was folded out in the Delamerian, was originally extended out there. So that's really interesting. Hello, Siri just wants to have a chat. Go away. And so, and also at the base of the crust, we're seeing a lot of activity here in our Macquarie Arc, which is cool. And the other thing is the Hydrogeochemistry zone really stands out over here. But let's go a little bit deeper. We can go through 100 kilometres, and things are starting to line up. And by the time you get to about, this is probably just above the lab, so above the lithosphere asthenosphere boundary, and we're seeing just these, it starts to tram track out along strike. It's quite interesting. And I know in the paper you'll read that it could be even more of a recent, rather than a fossil fluid flow or fluxing, it could be more recent, it could be related to Cenozoic volcanism. But what interests me with this, if I just track through, there's a sort of a dextral sort of corkscrew sort of rotation effect when you go up through the boundaries. It's quite interesting. Now, that could be some modelling effect, who knows, maybe I've had too much sherbet, but it is something we'd love to have a look at and see what the hell that's about. It does, if you want to look at Ross's model, he does have that aspect of rotation in his model, so that maybe there's something in there. Anyway, that's all to be done. We've got a arc linkage illuminating Auslan, because what you really need to do is you need to understand the conductivity in relation to some other data set. And we do have the seismic tomography. So we're looking to invert those data sets and just to try and get more of a geological basis for what all that means. Okay, let's come back down a bit get closer to the surface. Upcoming geophysical surveys. So this one is going to be fantastic. We've got Monday AEM. So here we are, Broken Hill down here. You can see we're in the Mundy Plain, and this is all Broken Hill group under here, as well as Neoproterozoic. And we've also got our 1600 million year granite, so 1590. So we're looking for expressions of interest come out next month. So look out for that. We want some infill. There was really successful infill done on the Cobar lines. So look out for that. We're going to be flying this by the end of the year. So it's going to be quite a sharp turnaround, as long as we can sort out some logistical details with GA. This is another collaboration with Geoscience Australia. We've got all the AEM off to the west here. And the other thing we've got, of course, is this Kernamona conductor, which I showed you earlier. So this is at 10 kilometres, coming right up into our AEM area and right at this boundary between the Namduka fault, where it sort of coalesces with the extension of the Mundy fault. So that's blooming interesting. That's where there. All right, and not only that, so not only are we going to get the AEM, we've got the Auslan, but we're also have got this work that was done out of the University of Adelaide by Ben Kay, Graham Heinsohn, Kate Robinson, and GSSA, well, she's working there now. They did broadband MT, so we're looking a little bit closer to the surface than the Auslan, and a lot more tightly spaced. And look at these conductors coming up. So there's the cross section there, going across the Kernamona, going into our Mundy AEM area, which is right in here. So this is about where the Namduka fault is, which is quite amazing. It comes in there like that. What I like here too, so Kalkaroo and Portia pretty much sit along strike from these conductors here. So that's really interesting. So I can't wait to get in here. We're going to be doing the airborne EM. We're going to be tying in a lot of the electrical data to see what we can find in our new area of study. So that would be great. Get on board. And while we're on the geophysics, another collaboration with GA. You're seeing a trend here. And we'll be flying this next year. So this has been long-standing. It's been like an itch we've really wanted to scratch, and we finally get our chance to do it. And that is to close off the airborne mag and radiometrics over Cobar and over the Jura bones over here in the Triton area. We know the deposits there respond well. They have associated magnetic anomalies. So this is going to be really interesting stuff. Look out for this next year for infill. All right, moving on. So now we're going to look at MinView itself. So you may not be aware, but we've done a huge job, our geophysics team, of updating the company surveys and making them ready for download. So straight after this, you can get on to MinView. Here's all the company surveys, and you can just simply click on any of these. You get a thumbnail of what it looks like, and you can just download that if it's available for download, if it's open file. So all of this stuff has been brought up to speed with consistent data. And of course now we've got access to this. We've used this in our latest merge. So we haven't done a statewide merge since 2014. This is the first one. And here's the data sets that we've brought in. Now remember, this is only open file. And let's not forget that next year we'll have access to a lot of closed file stuff that we'll be able to bring into a new statewide merge. But we've got this up and running in MinView now. And just to give you a taster, on the right's the old MinView, on the left's the new. So this is my favorite image, which is the gravity there and the colors. And we've got 1VD giving it some texture. And you can really see the effect of the new data. And it gives us sort of a 2.5D effect. It's so effective. So for instance, you can see the gravity response here to this intrusion, whereas you don't really see that on the other side. It's a bit more subdued. So yeah, look, this is really good. That's available in MinView coming up very, very shortly. That'll be ready. All right, Airbn EM survey. So this is one we flew last year. This is the biggest survey ever flown for AEM in New South Wales. It was a collaboration with Geoscience Australia. And it was very successful. We got an amazing results, and you can see the infill from these companies. I'm going to move on. All that information, there's a whole lot of information about the survey there that you can look at your leisure. But have a look here. This is a sort of a depth slice of the data. This is at 100 meters, and you can see these really conductive areas. And this is a lot of this is saprolite. You're in the weathered zone, and so it's a mixture. It's either these sort of clay-rich parts of the weathering profile, or salty water, or both. But I think the key message to this airborne survey and what it's showing is we are getting an impression of the weathered basement rocks. And it's actually helping us. We're interpreting at the moment. It's really helping us actually improve the mapping of the geology. And I'll just show you. We've been really lucky. The GA team are experts. We've got Ross Brody, who's quite amazing on this stuff, and we've also got Ian Roach, who is really good at interpreting this and making that translation from the data to the interpretation. So these are all of the different. I won't go through this, but this is basically the NRG. So NRG is the South African company that did the survey. That's there using the GA inversion codes. That's their inversion. GA then took that and just went a bit deeper into the constraining it and coming up with this is the depth of investigation. So pretty much below that, you can't really interpret. Then they whack it through the ANU supercomputer to come up with a Monte Carlo inversion. You get even more information out of that, and it helps you sort of look at what is more likely to be real and what's artifact. And then, for good measure, we contacted Intrepid, and we got them to do a 2.5D because, of course, you're sending a signal into the ground. It's not just going straight into 1D. You're actually getting a spread of the signal. They bring in all the data that they can to look across that, and that's the sort of image. It's a much more compressed signal that they're displaying there. So just having a quick look at the data. This got us excited. Initially, this is at Wagga Tank. So there's the drilling. These are the same drill holes here through the system as we're seeing. What we did pick up was definitely the base of weathering was very consistent there, but you can see this, how strong that conductor is above the deposit, and it probably blew away a lot of the signal there underneath of the sulfides, either that or the sulfides just weren't firing up with the signal. But then you've got this big conductor here, about 200 meters to the east, and we're really interested in that. But it also has this very discrete conductor that's also got a bit of mag high. So yeah, we obviously don't know what it is and needs further testing, and that's my message. I think with all of these things, that we're finding some really interesting things in this survey. Needs further testing. That's why you need to get onto your geophysical contractors and get them to work. So we're thinking this could be a superparamagnetic effect. So that's where you get these fine-grained iron oxides up in the near the surface. Could be in a paleo channel, which is what this response could well be. And because this is a time domain system we're flying, you get a sort of delay to you get this sort of capacitor effect in the iron oxides, and it comes out as a conductor that looks like it should be at depth. So that's possible. We still don't know. I still would say that needs further testing. But what does get me excited with the airborne EM is features like this, where we can see signals at depth, and they are continuous along strike, along a structure. So that's what we're seeing with the Aurora fault here. So we're coming up here up to the edge of the rim granite, and you're just seeing. I think this is a good evidence where you're seeing something geological here. This is not something that is an artifact, which, by the way, you can definitely see over here. This is the gas pipeline coming through, and look at the really distinct signal that you're getting from the gas pipeline. But luckily, those power lines and things like that are quite simple to pick out most of the time. So as long as you're aware of it, you don't fall foul of it. But usually they're quite distinct. But let's have here's another couple of ones that I'm interested in. This is Crowell Creek over here. This is and we know it's an east dipping stockwork, and that's the signal we seem to be seeing in the AEM. That's quite interesting. We know it's chalcocite being the major ore type. That should definitely fire up with the AEM. So to me, that's a really interesting one. If we move on, and here's the Cobar mainliner lode coming down through here. And our line here just goes north of Peak Mine. And yes, we're picking up something at depth. It actually flew right over the tailings dam, so hopefully it's not picking up things with that. But with our Intrepid inversion, it picks something up also in the 2.5D inversion. So it gives you a bit more confidence because it's such a compressed signal in the Intrepid stuff. And here's my roughie. So this is one I like at the moment. It's quite interesting. So this is Endeavour up here. So we're up in the northern Cobar basin. And we've got these late faults coming through here, probably related to Taberabran. And we've got this little conductor sitting in there. We know along this fault we've got mineralisation. And this one doesn't have a strong conductor over the top, so there's a chance that signal might be real. So let's look at, this is the same line looking at the Intrepid stuff, and it's got a really strong conductor at depth, and that doesn't happen a lot in the Intrepid inversions. Another little thing with the Intrepid inversions, they're quite cool because you can see here's our weathering, base of weathering here, or what we're interpreting as, and it separates out these two conductors. And we think that's real, and Intrepid think that's a real feature too. So you could well have some salty water right at your base of weathering, but some sort of clay-rich material up the top. That's how we're interpreting it. So yeah, really interesting stuff. Get online. It's all available from MinView, and just have a cruise around. It's really interesting data. All right, mineral potential mapping. So we embarked back in 2017 on a mission to map our major mineral systems. And the reason for this is we need to, as a government agency, we've got to protect places from resource sterilisation. And so we've got to have an idea of where mineral deposits could exist outside of known mineral deposits. In other words, we've got to predict where mineral deposits potentially are, and to help the land use guys when they go into negotiation with other land users. And we've done it, we've finished it. So we have now 15 major mineral systems complete. We couldn't have done this without the help of Kennex, which is a NZ-based consultancy that do spatial analysis and do they're just experts on this stuff. And we've now got all of these mineral systems, and we've just finished Cobar. And I don't take that literally. I literally threw that on there about 2 nights ago, so it's not perfectly in place, but it will be very shortly. We'll have that out in MinView. Just got the report to finish off. So let's give you a sneak peek of what to expect when you download this. So it's in the central Auckland. I showed you before the tin tungsten system, but we, thanks to the work of the mineral systems team, they're able to also recognise these 2 events where you've got a copper gold dominant event and a lead zinc dominant event. And so with a rift sag phase of the Cobar Basin at around this time frame, with a lot of mineralisation coming in, copper gold dominant, and with a lot of magmatic tenor, so magmatic fluids, whereas this Tabarabran inversion phase, you're seeing a lot of mobilisation of lead, zinc, silver into these faults. So yeah, 2 distinct phases, and you can see the difference between, even though that there's a lot of overlap, obviously in a lot of Cobar types you get copper, gold and lead, zinc, and they're often together, but they are just distinct in their timing. But you can also see there's a distinction in how they've been mapped, so that's really interesting. And this just gives you a sort of another feel for the actual data and how successful it was. So basically, what we're looking at here in here is the area reduction. So we're reducing our area that would be considered prospective, because this is our prospective values going up in this direction. So basically everything, what's that? East of that line is considered prospective, which is why we've got our colorings here. So those colorings you could see in the previous slide, that's what these colors relate to. So everything in there is prospective, and you can see the full range of the mineral system here. So this is the most prospective, and not surprisingly, it's our big daddy. So it's the CA mine, it's the Peak, it's Great Cobar, and they're the most prospective. But we're looking at an entire mineral system, so we're also getting the edges of the mineral system. Maybe they don't exactly belong in it, but we've got Mundo, Browns Reef, Gundaroo for our lead zinc. So they may well be earlier deposits that have been reactivated, but they're on the edges of that system. They're still prospective though, which is interesting. Same goes for copper gold, where we get our big daddy, CSA again, New Occidental, Great Cobar, Mallee Bull in here. But our outliers are things like Mineral Hill, where we know we've got good epithermal textures. There's epithermal parts of that system. It's quite strange and overprinted. And we've got McKinnon's, which is essentially a gold mine. So yeah, really interesting. Look out for that data and the report coming up soon. The other thing we've been doing in Cobar is hydrogeochemistry. Now this is in collaboration with CSIRO, and they are experts on this sort of stuff, where they measuring super precise water samples. We've got 88 water boils sampled, full range of trace elements. We've got also isotopes to help us date the water. And I noticed that actually I was just talking to the GA guys, were just showing where there's a company west of Telfer that's just been pegging ground based on the hydrogeochem results by the same team from CSIRO. So there is a lot of interest there, and we're seeing in here, this is we can pick out the best indices that are showing you where you might find these copper gold related Cobar types, and also for our more multi-point, multi-element anomalies. We've got these 3 areas, one interestingly up in Louth, but also this is extension of the Warara fault, where we saw those AEM anomalies at depth. So that's interesting. definitely worth a look on the western side of the Riverina granite there, and also down here a bit further south near Lake Geological. All right, getting down to it, but also some fantastic work here from Joe Schifano, who was an exploration geo out Cobar, used to work for us as well. He's doing a PhD and he's looking at biogeochemistry across the region with David Cohen at UNSW. And you can see the coverage. Who knew there were this? I certainly didn't know there were this many cypress pines in the Cobar district, but he has just been hammering them out. And he's got this great regional network. He's done Niton. He's now getting all the results back from ALS. So, and he's getting some great results. It looks like the tungsten and the lead are really important as pathfinders to mineralisation. And he's gone in and done all of the red dots here. That's where you've got, he's gone in and done the deposits, the prospect scale sampling, come out with really good results there. And look, here's the call to arms. If you are a company out Cobar Way in any of these yellow dots, give him a call or give me a call, and I can get you in contact, and we can work a deal out to analyse this. You know, get in there, get some samples, and give you another great clue to finding these deposits undercover. All right, so that's kind of it. Just looking ahead at the future, of course, our focus is really going to be on MinEx, and a lot of our work is going to be funneled into that. But I would say my big thing, and you might have heard me talking about this, I still think fundamentally we must do field work. We've got to be boots on the ground field work, and that includes basic geophysics as well, getting the geophysics out there. We have to have that connection with the rocks on the ground. That's the only way we're going to ensure we get quality data. And speaking of data, we've got all this sunset clause data coming in next year. That's going to be a big focus for us. So really, we've got to ensure that the information, we understand the rocks we're looking at, and that we can provide you really clean, well integrated data. And that's what I'm showing here. So we're making a lot of inroads to making sure that all of our point data is related to all of our vector data, for instance. So now we've got these systems that, so for instance, if you get a new age on a granite, you can put that will go into our point database, then overnight will get replicated into our vector data to constrain the granite as it appears. And when you go and click on that granite and you find the age, that's got the latest age information. So that level of integration is really important, making sure we're always singing from the same song sheet and that it's always the best available. And really, to me, that is the best way. If we're going to go exploring undercover, we've got to be predictive. If we're going to be predictive, we have to have the best available data, and there's just so much to do yet on the ground with basic mapping, fixing our data up, and this comes to 3D. And I just want to show you one more thing. Giovanni Spampanato, he's just finished this new wireframe 3D model. Now, it looks pretty simple, but there is so much to this. Go on to MinView, download it. It's really fascinating because this brings in all of these faults in here. These just the major fault networks. They're all completely compatible with all the information that's in our seamless, and we are going to basically create a physical model of this, showing where all the basins are, where they sit on top. So this is going to be a really important work that we've been doing, and to springboard from this into our cover work. So thanks very much for listening.
Thank you so much. If anyone else has questions, please let me know. I've got one that's come through. Can you please elaborate on the broadband MT technique you mentioned?
Yeah, I might actually flick to Rochi there, because he's much more on the full bottle on that than I am. So if Rochi's still there.
Yeah, I am. He just gave me a conniption. Yeah. Oh, golly. it's a sort of a intermediate MT method. The Auslan data that John was talking about is a very long period MT, which look basically, if you leave MT stuff out long enough and you listen to the right wavelengths, you can actually image down to the core mantle boundary. The long period MT that we do images basically into the asthenosphere. Broadband MT has a shorter listen time, slightly different frequencies, so we image down to the base of the crust. And it's really good for imaging you know, individual cratons and sedimentary basins and things. Does that sort of answer the question?
Sound good to me, Rochi.
Okay.
Yeah, somewhere in between the not as deep as the long wavelengths as the
the long period. Yeah, so
yeah.
it gives you a much better picture of what's going on in the crust. We put the stations a lot closer together. The models are more detailed.
I was going to ask one. What's the broadband magnetotellurics?
Okay. So yeah, that's what we just. Who was asking that? Sorry.
Me, Kim.
Oh, g'day, Kim. Yeah. So yeah, that's sort of an intermediate technique, looking at a sort of medium period. But yeah, Rochi just explained it a lot better than I do. But basically, you're going to see it at a higher level of through the crust than you are from the Auslan, which is obviously looking right through the lithosphere. That's how I understand it.
That's all I needed. Yeah.
Yeah.
Okay. So, you know, actually, the method, do you need us to talk about how it works? Or?
Oh, why not? If you're offering. Go on,
So
Rochi. It's always good to have a lesson.
Oh, here we go. All right. Now you're really stretching me, all right? Because I'm a geologist who knows a little bit of geophysics, okay?
I don't understate yourself. You know a lot.
So what MT is looking at is the magnetic and the electric fields in the Earth. Okay, and these are huge fields that circulate through the Earth, and we're looking at the variation in those over time. And so the really long period work that we're doing for Auslan, we put out the stations every half degree across Australia, and it gives us a picture of, you know, a wedge of the Earth down to that core mantle boundary. Oh, I'll turn my camera on. And so the broadband looks at slightly shorter time periods, and so it doesn't image as deeply, and it gets to the base of the crust basically. We can image the base of the crust, so say, you know, down to, I don't know, 30-40 kilometres, something like that. So we use different kinds of MT, different frequencies to image different parts of the crust. And there's another one called audio frequency magnetotellurics, which is really, really cool for imaging shallow sedimentary basins that only penetrates to about 2 kilometres. So we run all those kinds of things out, and they're all complementary as well to airborne electromagnetics. And so you can stack all this electrical data up and get a really good picture of the near surface down to as far as deep as you want to go. Yep.
Thanks.
No worries.
And a bit of chat there about MinView. Yeah, I mean, I'm biased as well. I think it is the best of that. And the reason I say that, and I can see Ariane making the point that, yeah, it's the data. And yeah, your data has got to be good. But we call MinView Fifi. It's fast, intuitive, fast, informative. And that was the aim of the thing. But I just like how quick it is. Like, you can get our data up, and it's just easy to use, and you can get to the data pretty quickly. That's what I like about MinView, but I'm obviously biased.
Have you modelled that from somewhere else, or have you been influenced by, say, another system in the world that has sort of influenced you at all? Because I can't find anything else, certainly not in Australia, not another state that has a system anything close to what you guys in New South Wales have generated.
Yeah, it's interesting because a lot of other platforms use GeoCortex with an Esri based, and you know, it gives you sort of an ArcGIS-like view. But I find them they tend to be quite slow and a little bit clunky. That's my opinion, of course. with MinView. No, it was built from the ground up. Had cesium and an angular platform. So yeah, it was quite unique, and it's unique in that sense. Yeah, I've never seen anything really like it either. Yeah.
Got another comment. I mean, I know there's been some good discoveries in New South Wales recently. If you go back to 2015, there's only about 6% of the state was held under an exploration licence. MinView was still far in advance of any other state in Australia in relation to the information that was provided in that system. It'd be nice to get a sense on whether the increased investment in New South Wales in the last 18 months can have been influenced somewhat by the data to us.
Well, if we're talking to our higher up in government, of course it's all about us, because that's how we get money. But we're all victim. Well, we're all related to the commodity cycle, of course, and at the end of the day, it's discoveries that bring in the investment, and Boda at the moment is a great example, and also the work that Peel Mining have done, and all of those discoveries in New South Wales. That's what brings people in. We really try to fish out. It's really hard to make that direct connection with what we do with exploration efforts. So, like, anytime you guys can give us a boost and tell us, well, okay, hey, you know what, the reason I found this was because I went and looked at your data, and then that made me chase it up and made me collect my own data. So that really helps our case, because we're in competition with every other jurisdiction in the world to try and bring in exploration. So we'll do whatever we can, and put whatever, just help us as much as we can. But yeah, it's hard to make that direct connection.
I'm sure people will be impressed. I mean, there's a few TSX listed companies now here in Australia, and also a lot of the West Australian companies working in New South Wales. I'm sure they're pretty impressed with what they find.
Yeah, thanks. Yeah, thanks for that. And having been in WA, when I was in WA, didn't know much about New South Wales. I just knew about Archean gold deposits. And yeah, I think that's still a fair bit of the case. But yeah, you're seeing more mid-tier WA companies coming over, and they're trying their luck here, trying to jag a new Katie or getting a new Cobartite. Yeah, for sure.
What year model is your Stratocaster?
Oh, that is 2002. Absolute beauty. I love it.
Play us a tune.
I'm not. No, I'm not going to do that. I'm not going to embarrass myself. But I do.
You've got to play Stairway to Heaven now.
Play
John.
Stairway to Heaven.
Okay, Sam. I refuse to learn Stairway to Heaven. But yeah. But even though Led Zepp's one of my favourite bands, but there you go. Then we can put a plug in here. So Mines of Mines is happening again, September next year. So yeah, look out for that. We're going to have a really good field trip. Going to look at a lot of Northern Moan core, Cadia. So yeah, look out for that.
2020 or 2021?
2021.
Yeah.
Yeah. In Orange. It's back in Orange, which is great. Last time we were there was 2017, and we got to see North Parks and Tomingley, and what else we see, and the pub at various places, Moan.
Come along too.
Yeah.